will be about pandas. You remember pandas is a framework that I described in the past. It's a Python package that we use for, um, it's a Python package that we use to deal with data. And this data, if you have data frames or Excel sheet or anything like this, it's easier to deal with it using pandas. Now, pandas is not installed by default in here. And remember when we talked about Colab, we mentioned that every time that you are refreshing your Colab, you need to install your packages again. And to install, if you are using your personal computer within a virtual environment in Pandas, you do not need to do this every time. So you can do it only one time and that's it. Now to verify that, I do not know if I have Pandas or not, so I'll do import Pandas. Now, I think it's installed, but if it's not installed in here, you need to say pip install pandas. It will download and install pandas for you. But I think it's already installed. Yeah, requirements already satisfied, so it's already installed at my computer. Okay. Now, I will start by importing pandas. And since every time I wanted to use pandas, instead of typing pandas again and again, I will use an abbreviation. I will use as PD. So I can, every time I use it, I use PD instead of using the full word pandas. Let's start by creating an array or a list of data. And this list of data, we call it data frame. So what I will do is I'll create a data frame. In real life applications, mostly you will read this data frame from an external file. But for simplicity, for now, I will not read it from a file. I do have a data frame that I created for you guys. So I'll just create it in here, copy it and paste it so I can tell you what is it exactly. Now, the data frame that I created, I'll start with a keyword, with a variable name. Let's just call it data. And then my data frame will be enclosed between these curly parentheses. So anything between these curly parentheses will be the data frame. So just to give you an idea what this data frame is, let me just print it quickly. Print. So now you can see in here, when I printed this, this is not clean. It's saying that the patient ID, similar to how it has been created in here, drug and those milligram frequency, age, adherence percentage. So instead of this, so what I will do, I will convert this data into a data frame so I can deal with it. So I will call my data frame as DF. And to create this, convert this into a data frame, I will go to Pandas data frame. It's PD dot data frame. And it will immediately convert this data into a data frame. Let's just print DF. Now you can see your data frame is organized as if it's an Excel sheet. I do have indices, index, every row is separate, and I can deal with rows or columns. I can apply some calculations and some operations on columns or rows or all of the columns. One thing I wanted to bring up in here, if you can, or in most of your cases, you will be dealing with data frames like this. You have a data set for certain drugs, or you have a data set, clinical data set for certain patients, or you have, so whatever the data set that you have, I highly encourage you to use data frames, pandas data frames. Okay, what does that mean? That means you can read the data line by line. You can deal with it without data frames, without pandas data frame. But my recommendation to everyone is try to use pandas data frame for the following reasons. First, pandas data frames, in the background, they are running in an optimized way where they can run in parallel. For example, if you wanted to create a code that runs on my computer or your computer and it might take 1 hour, if you are using Pandas data frame, most likely it will run everything in parallel and it might take much less, might take half an hour or 15 minutes sometimes. 1. 2, it's easier to deal with it. 3, most of the machine learning packages and libraries, they can deal with data frames easily. 4, you can save and read files easily in data frames. You can transform them much easier. You can interact with them much easier. So in general, data frames are the go-to for us whenever we are dealing with data. So I highly recommend everyone to work with data frames. Okay, now let's get back to our data frame in here. So what I've done, I read a list of patients. So this is a regular, typical list, but I'm trying to assign it a name. So I have a patient ID. This is the same list that we have learned in the past when we created lists in Python. This is another list, which is the drug name. This is another list, which is the dose and its numbers. So I'm not enclosing them between single or double quotations. This is the frequency, this is age, this is the adherence percentage. So you can see I'm dealing with them. I put them together. I use the column notation. Now this will be the header of the data frame, and the list in here will be the column. And you can see the number of columns is the same for all of them. Let's try to delete this one and make the dose milligram with 5 items instead of 6. I tried to run, now it's giving me an error. It tells me that one of your columns, it doesn't have the same number of items. So all arrays must have the same length. And this is the problem that I'm running into. I put it the same. Now I have this list. Again, imagine that you are reading a CSV file or an Excel sheet. We will do that later on. And now you are working with it. I converted it to a data frame. I printed the data frame. And now let's see what we can do with the data frames. Let's look at basic inspections of data frames. We call our data frame as DF. So I type DF, enter. Now I can see it. Now you can type, I wanted to see how many columns and how many rows I have. So you can do data frame.shape. So this is number of rows and number of columns. Let's print them in a more friendly format. So the shape, let's just type it in shape. We have number of rows and number of columns. This double quotation, and this is the shape that we have. So the shape of my data frame is 6 and 6. Now let's try to see what columns we have. Let me just print the columns. Let's just print. Columns in this data frame are, so I'll go, what's my data frame name? It's DF. When you hit the dot notation, it will tell you, for example, this is shape. Or you can go to every single column of these columns, or you can go with columns. So I'll read the columns. Now, if you print them, they will be in a weird format. So what you need to do is just use dot to list. This will convert this is a function that will convert all of your entries into a list. And now you can see them in the form of list. Let me just comment this out. Now this is a list. You can go and deal with them one by one using a for loop. Let me just use a for loop. So I can just say for a call and df dot columns dot to list. And now I wanted to print the columns one by one. And I can just say a call. I forgot to add the column. And now I can print them one by one. So it's easy to deal with it in the form of a list or array using for loop. So I printed the columns. I can also look at, let's just add one space. So I can print a blank line by saying print and without providing anything. Now I have a blank line. And I wanted to see the first 3 elements within my list. Imagine you are dealing with a list that contains 1 million entries. I do not want to print all of it. So if you try to print all of it, it will, your computer will freeze. بيعلق جهاز الكمبيوتر تبعك. So what you need to do is you can go data frame dot head. Head by default will show you the top 10 rows. So you can just say head 3. Just show me the top 3 columns. Now let's just make this as comment. So I want to see the top 3 rows, and you can see there are indices in here, indices for them. Now, how about if I have 1 million entries in my data frame, and I wanted to see some information about the data frame? So you can say dot info. open, close parentheses. This function will provide you some quick, simple statistics about your data frame. So it tells me that this is pandas data frame. We do have 6 entries. They start from 0 to 5. The columns are 6 columns in total. I do have them numbered in here from 0 to 6. I have patient ID, and it's not null. It's an object. The data type is object. Object is a very general data type. Remember that we talked about string, we talked about integer, float, characters. So object is a very general data type that you can convert it later on to any other data type. Drug is object. Dose milligram is an integer. Frequency is an object. Remember that was a string. We can convert it to string later on. Age is another integer, and adherence percentage, it was a percentage, so it was a floating point value, so it's float. Now we have seen the information. You can also get some sort of a quick description, some statistical descriptions about your data. So to create this description, you can go with DF. Every column you find average, standard deviation, mean, median, 25 percentile, so 20. Instead of doing all of that, you can just use df.describe. And df.describe, it will tell you these are the numerical columns that you have. The first column is the dosage milligram. You have 6 values. The mean is 184. The standard deviation is 245. The minimum value is 5. The 25 percentile, the 50 percentile, and the 75 percentile, the maximum. And it will repeat the same for all of them. By the way, if you are dealing with Colab, you can open this into a table, like interactive table like this. But for the sake of my work, I would just like to deal with it as a code. Now, if you wanted to do these calculations by hand, it might take you 30 minutes or 45 minutes to calculate them. Whereas what you see in here is just one command that will calculate all of the descriptive statistics. We call them descriptive statistics for your data frame. And it's easy peasy. Now, if I would like to get, now I created the description in here, but I would like to get, like, let's say I wanted the dosage or the adherence percentage. I wanted to find the average of it. So what you can do is you can go to the data frame itself, open parentheses, and deal with it as if you are dealing with an array. Between double quotation, you can say, I wanted to see the adherence percentage. Now, if I take the adherence percentage, print it, it will print me all of the values. So there is one value that's missing. We use it as NaN. Now you can just say, I wanted to see the mean. Now this will bring me the mean, so I can just print it. So this is the mean. I wanted to find, for example, the minimum value. So this is the minimum. I wanted to find the largest value. I wanted to find the maximum. And I wanted to find the value in the middle. Remember, we call this as median. So I wanted to find the median. I wanted also to find how many values I have. So you can go with count. So this is the basic statistics that we have. Remember that we have one value that was not available, missing value, and so it's not counted. So what else? So if you wanted to see what other statistics you have, just put the dot notation, control space, and you can see we have mean, median, maximum. We have absolute value if you wanted to see the absolute value of all of your values. So it will print all of the values in absolute value, قيمة مطلقة. You will not see any negative values. You can add something, append something, aggregate. You can show any, like we'll talk about this, any apply, argmax, argminimum. You can convert it to array, to list if you would like to deal with it as a list. I'll show you in a minute. A list, for example, you can just say to list. Sometimes this is useful. You wanted to deal with it as a list in a for loop. Okay, so these are basic summaries and statistics that we can apply on a specific list. Sometimes what happens, you wanted to bring up or filter things. Now, within data frames, it's easy to create filters. So this is my data frame still as is. So I decided I'll go with print. And this is printing the data frame. You can see you can print it in here. And I wanted also to print only the drug column. So you can just say drug. and print it. So it will bring me, is it drug or drugs, I think. Okay, I don't know what is it. So what I will do is control space, and it tells me it's a drug, D capital. Now I was able to print it, and you can see it's printed as one drug. Now I wanted to select multiple columns together. Let's just make this as a comment. So you can just go within the square parentheses, add a comma. I wanted to print patient. We have patient ID, I think. Print, so you can print the patient ID. So if you wanted to print multiple ones, you need to include double brackets, this square parentheses. So you include two of them. And this is what I was missing. Now, if you wanted to print, for example, those milligram, and now you can see, I think it was D uppercase. You can see I am able to print all of them, and you can filter them. Now, I wanted to change the order. I do not want to see the drug first. I wanted to see the drug last. I wanted the patient ID and dosage milligram, and then the drug, for example. So the order doesn't matter, and you can select whatever you want. Now, let's say I wanted to get, again, I'm looking at the same DF. I wanted to filter. I wanted to see the adherence percentage is less than 80. So let's see, do we have anything less than 80? I have two of them. So this is what we will do. We will go with DF, and then we will say, I wanted to see the DF with adherence percentage less than 80. Now it gives me this list. So let's try to divide this into two steps. The first step, let's just comment this out, is I wanted to see anything that has adherence of 80, less than 80. If I print this, will be a Boolean list. It will be true, false, false, true, something like this. Now I can save this into filter 01. Let's call it filter 01, and I can print this filter. Sorry, it's filter 01. So I can take this filter and print it. Now, remember that's false, false, true, false. So these are the values that we have within the DF. I can print the DF. Now, this associated false, false, true, true, false, true, false. And this is what we have calculated in here. Now I can take this DF and put the DF, filter 01. Okay, so you either use it like this, or you can put it all together within one filter. Let's just put it as a single line, which is, again, it's the same story that I described earlier. It's a style of coding. So some people like to type it like this, and some others would like to type it as two steps. Now, okay, let's save it into a variable. So this is no adherence. So you can save it into a variable, and then you can print this variable. Sorry, let's just type no adherence. Okay, so I filtered this, and this one now is a new data frame. So low adherence is a new data frame now. That's a subset. Sorry, low adherence is a subset of the big data frame. Is the big data frame DF is changed? No, it's not changed. You can see in here, this starts from 2, 3. The original data frame still as is. Now, let's say I wanted to find out multiple filters. So the multiple filters that I have. So the first filter, I wanted to find the multiple adherence, keep it as is. And add to this, the age is greater than 60. So I have the age in here. I wanted to find anything that's greater than 60. So what I can do is this. Enclose this between double quotation, or parentheses, sorry. Remember, we talked about the and. And means I have both the right and left. They must be true to have a true value. Now I said data frame adherence percentage is less than 80. And let's copy this. And I wanted also, instead of the adherence, I wanted to add to the adherence also. I wanted the age. So I called it age. And I wanted anything that has an age above 60. Let's just print this value. And we don't have any values that are above 50, so it's empty. Let's try something else. Age is, oh, sorry, this is above 60. So I do have two values in here. Now you can see I combined multiple conditions, adherence and age. So you can add the third one, a fourth one, and so on and so forth. And now we can just declare this as, where is it? Risk. Let's just call it the risk. And then we can print risk. And now I can also, instead of printing everything within risk, I can select, remember how I can select just a few columns in here. So you do not need to select everything. Let's just take drug, dose, and frequency, for example. And frequency, and I need a comma in between. So you can select, and this is a third data frame. So now I have 3 data frames. This is another data frame, it's called the risk. The previous one, we call it low adherence, and the original one was DF. So we created 3 data frames. The next one is, we will get into more details about how I can deal with the data frame. For example, how can I sort it? How I can add more columns, remove columns, how I can deal with missing data values, how I can group data frames, how I can interact with data frames and read CSV file, for example. I will pause in here for any questions.